For CO2 to leave cells and go into red blood cells, there are two different processes which can be used. The first of which is where CO2 gets turned into carbonic acid and leaves the cell. So here is a red blood cell, and here is the tissue. Let's mark the red blood cell. And here is a hemoglobin inside the cell that contains O2. So we're going to say HbO2. Now, inside the red blood cell, there is lots of water, H2O. So the tissue, let's say it's a bunch of muscle cells, it produces CO2, which diffuses through the capillary wall right here. And since it's a small enough molecule, it can go through without much of a problem. So then it's up in the bloodstream, and it comes into contact with a red blood cell. And there is a enzyme inside the red blood cell called carbonic anhydrase. What that does is it catalyzes a reaction between the CO2 and the H2O, where it creates carbonic acid. Carbonic acid being HCO3 negative. This is carbonic acid right here. So when it creates the carbonic acid, it leaves the cell. Now in this process where this gets turned into carbonic acid, the CO2 loses an H plus. So an H plus is created. Now H pluses are allosteric inhibitors of the HbO2. So when the H plus comes into contact with the hemoglobin, the O2 will be released. So the O2 is released. And the H plus gets put into the hemoglobin. So you're left with carbonic acid in the bloodstream, which makes this red blood cell, since it gained an H plus, that makes this red blood cell slightly positive. Now, to counteract that, some chlorine, Cl negative, comes in. Now, it's negative because the carbonic acid is negative when it leaves. So that way it balances out the charges in the red blood cell. So then you're just left with red blood cell with less water, the CO2 gets converted into carbonic acid, and you're left with hemoglobin with an H plus. Now, the H plus kicked out the oxygen. So the oxygen that was once in the hemoglobin gets kicked out into the bloodstream. And now, since the hemoglobin kicked it out, there's now a whole bunch of oxygen inside the bloodstream. Now, the O2 diffuses out of the bloodstream into the tissues because there's a high partial pressure. There is low O2 in the tissue because it's converting it into CO2, and there is a high O2 in the bloodstream. So then this O2 goes to where there's less of it, and it diffuses into the tissue, which the cells take up and they use in their respiration. So in the very end, you have carbonic acid in the bloodstream and a red blood cell with an H plus on the hemoglobin and chlorine inside the cell.